How many times have you taken a call from a client to tell you that something isn't working? These calls can go one of two ways. It could go like this. Hello, Matt speaking.
Hi Matt, it's Philip here.
Hi, Philip.
Are you well?
Yes, very well indeed, thank you.
Excellent. Sorry to disturb you, but just having a few problems here, and I'm sure there's something silly and more than likely something that we've actually done. Any chance you could swing by, take a quick look?
Yes, of course.
And then, hey, while you're here, let's pop out for lunch.
Oh, how wonderful.
It'd be great to see you.
Yes, and you.
Yeah, sure. Okay, I'll see you in a bit.
But let's face it, it rarely goes like that, because it usually goes like this. Hello, Matt speaking.
Matt, Philip here. Yes, nothing works. Never has. Nothing's ever worked since it was all put in. No, never ever worked. Very disappointed. And it's the end of the world for us.
This course will introduce you to the basic tools you need to equip yourself with before attempting any troubleshooting, as well as show you some common techniques which help you to get to the root of the problems more efficiently. In the Importance of Network Designs video, we identified the single biggest cause of network failure as being people. Now, this doesn't mean we can automatically blame the customer for anything going wrong, especially on the network. But it does reinforce the importance of making sure the network which you deploy your SDVoE system on is thoroughly designed and documented. Why? Well, that's easy. It allows you to put everything back as you left it before trying to do any kind of troubleshooting. There's a really good chance it will all start working again just by doing this. And that's all the proof you need that wetware was indeed the culprit. So, you put it all back as it was and you're still getting problems. Now it's time to break out some software to give you some ideas as to what's going wrong. There are a number of network troubleshooting applications available on the internet today, and most of these are free. However, there are some key points to bear in mind before you get stuck in. There's a good chance the network port on your laptop is only a 1 gigabit port, and if you're using wireless, you've got absolutely no chance. Because SDVoE is a 10 gigabit system, as soon as you try to intercept any video streams from an endpoint, your network port on your laptop will be instantly overloaded. One solution is to tell your transmitter to stream audio only. Audio streams are small. They easily fit within 1 gigabit, and while it won't be a video stream, it's still a stream, so you can still see if there are any networking issues from that SDVoE endpoint. Alternatively, if your computer supports it, you may want to equip yourself with an external 10 gig network interface, which will allow you to investigate video streams from your endpoints. When you need to monitor the stream of an endpoint, you may need to mirror the port of that device first. Port mirroring takes place within the network switch and is essential to allow the software on your laptop to be able to see the traffic intended for another device. Mirroring a port is a lot like the name suggests. You take all the traffic that's destined for port X, which contains the traffic you want to check, and make a perfect copy of it to port Y, which is where your test equipment is connected. Port mirroring is an important feature for testing an SDVoE endpoint. Simply unplugging the endpoint from a network port and plugging it into your laptop instead will prevent you from testing the system you set out to investigate in the first place. It may be that you're not able to or not allowed to mirror a port on the network switch. If you do have control of the network switch, you should reach out to your vendor to help you with this. However, if you don't have control of the switch, this is a conversation that you need to have with your IT team. Once you've made sure your hardware environment is correctly configured for testing, it's time to open up your software. Now, this screenshot is from Wireshark, one of the most common network troubleshooting applications available. It's worth just having a look around it to familiarise ourselves with the layout first. The source and destination addresses identify packets moving in and out of the endpoint. In this screenshot, we can see a series of discovery packets being broadcasted by SDVoE endpoints. In this case, all using linked local IP addresses, allowing the SDVoE API server to identify them. The destination addresses used is the clue to identifying the fact that they are broadcast packets. The protocol column identifies the protocol which is sending the packet. So here, we're observing discovery packets in blue being broadcast by endpoints using UDP, User Datagram Protocol, and in red, multicast packets being sent from an endpoint using IGMP, Internet Group Management Protocol. This section towards the bottom identifies the data contained within the layers leading up to the protocol which is being highlighted. The top data packet is highlighted, and we can see it's a layer 4 UDP packet. So this grey area shows the frame at layer 1, the MAC address information at layer 2, the IP address information at layer 3, and then the UDP data at layer 4. Network troubleshooting can be a complex process, and attempting it unprepared is highly unadvisable because it can often create more problems than it solves. The Network Basics category here in the Academy contains a wealth of courses to help you understand the network terminology and processes you should be comfortable with, and that you can access these courses easily by clicking this link. In the next course, we'll take a closer look at some of the problems you may come across with an SDVoE network and introduce you to a logical approach to solving them.